Hello and welcome to our lesson on radicals, cube roots. First, let's talk some definitions. The value of a number or a variable that when you multiply it 3 times in a row will equal the radicand. There's your index. That tells you it's cube root. We're looking for some number that goes 3 times in a row. And your radicand is 54, and then the funky check mark is your radical sign. So we would say that we need to find the cube root, or sometimes called the third root, of the number 54. So much like when you have to simplify them, you're going to make a factor tree first. Let's break them all down to prime numbers. So I know that this is going to be an even number, so I can break it down by 2's. So that goes in there 17 times, 27 times. Then we have 2 is your prime number, and I put a dot underneath to help me keep track of all of them. And I know that 3 times 9 is 27. 3 is prime, 9's not. So let's break them down. 3 and 3. So it turns out that I multiply 3 times 3 times 3 times 2, and I should get 54. Pairs go out. In this case, it's triples. Groups of 3's go out, and singles stay in. So when we broke down 54 into prime numbers, we ended up with 2 times 3 times 3 times 3. Since this is looking for cube roots, we're looking for triplets, groups of 3 that can come out, and any singles have to stay underneath. So it turns out that we've got one group of 3's and a single 2. This is what it would look like then. That one group of 3's, you only take in and write it one time. It indicates you have one group of that. You have one group of 3's, and that single 2 goes back under the radical sign. Be sure to simplify the radicand if you can. 2 can't be broken down any further, so we're done. You're always going to want to go back and double check your answer. The new whole number that you have that's sitting outside the radical, in this case our 3, needs to be multiplied by itself the number of times the index says, which is 3. And then you're going to multiply that answer by the radicand. If you did all that correctly, the answer that you get on your double check should match the radicand that you started with. Let's see if that works. What they're telling us is to take the whole number 3 and multiply it the number of times in the index, which is that teeny number. So they're asking us to do 3 times 3 times 3. Alright, so 3 times 3 is 9, and 9 times 3 is 27. Now you're going to multiply that answer that we got, 27, by whatever is still under the radical sign, that leftover radicand of 2. So if we take 27 2 times in a row, we're going to end up getting 54. And that was our original radicand that we started with, so that means that this answer up here is correct. Let's try a couple of examples. We've got the number 24. First we have to prime factor it. 2 and 12, random. You could do 3 and 8, 6 and 4. They're all going to work out to the same primes at the end. 2 times 6, you could have done 3 times 4. It'll still work. And then 2 times 3. Now, since this has an index of 3, we're looking for groups of 3. I have 2, 2, and 2. And then we have our leftover 3. So that means the group of 2's come out, and that lonely leftover stays underneath the radical sign. Now we double check. We're going to take 2 to the third power. So that means we're going to do 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. And then we take our answer and multiply it by the radicand. 8 times 3. We end up getting 24, which was our original radicand. So that means this answer right here is correct. All right, let's try the next one. We're going to take 64 and break it down into primes. I know that it's a perfect square, but I need to keep breaking it because I'm not looking for pairs, I'm looking for triplets. So now I have 4 times 2, prime number, and another 2 prime and 4. Let's break 4 down. We have 2 and 2, and then 4 is 2 and 2. All right, index says 3, so let's find some triplets. 1, 2, 3, 1, 2, 3. I have 2 sets of triplets. So I take out one set of triplets and the other set of triplets. Nobody's left over, so I don't have a radical sign. So my answer should just be 2 times 2 is 4. Let's double check. 4 raised to the third power. So we're doing 4 times 4 times 4. So that's 16 times 4 is 64. It turns out that's correct. It matches our original one that we were trying to break down. So that means our answer of 4 Our final answer right here of 4 is completely correct. All right, 108, and we're looking to break it down into primes. So how about 2 and 54? How about 2 and 27? And 3 and 9? And 3 and 3. All right, index says groups of 3. 1, 2, 3. And I don't have enough to make another grouping of 3, so I've got 2 lonely 2s that are hanging out. So I've got my group of 3s, and then I have 2 times 2 left over. They go back under the radical sign, so that means that my final answer is going to be 3 radical 4. Let's double check. I have 3 to the 3rd power, because this is an index of 3. So 3 times 3 times 3, that's 9 and 27. And then I'm going to take 27 and multiply it by 4. And that's going to get me back to my 108. It matches, so that means this right here is the correct answer. Let's try the last one on the page. We have the number 54. This one, let's do 9 times 6. We've got 3 times 3 primes, and then 3 times 2 primes. Now I'm looking for triplets, 1, 2, 3, and then our leftover. So I have 3, an index of 3, radical 2 with the leftover. Let's double check. 3 to the 3rd power, 3 times 3 times 3, it's 27, and then we're going to multiply it by our radicand, which is 2, and that's going to get us back to 54. It matches, so that means right here is our correct answer. Okay, so let's see how this looks in algebra. The only new thing that we have to deal with now is our variable. That's okay. Let's start with the 108 again. So 2 times 54, I've got a prime. Then I've got 6 times 9, and that's 2 times 3, I've got primes. And then 3 times 3, primes. Now if I have x cubed, that means that the exponent tells me how many times in a row I need to write my variable. So I have 3, so I need to write them 3 times. My index is telling me find groups of 3. I have a group of 3 of x right there. Then I have a group of 3 3s. However, I have 2 lonely 2s left over. If I had one more 2, I'd have another group. But since there's only 2 of them and I need 3, they can't come out. They have to stay under. So I have a group of 3s times x, and staying under the radical are my group of 2s. 2 times 2. And if we simplify that out, we've got 3x, and these are all index of 3. I've got my radicand, my index of 3, and then 2 times 2 is 4. If we double check our answer, it's 3 to the 3rd power, so 3 times 3 times 3, which is 27, and then we're going to multiply it by 4, which is going to get us back to the 108. That matches our original. Now, x, and you multiply it by whatever your index is. I've got 1x multiplied by 3, that's x to the 3rd, and this is our original as well. So it turns out that this is our answer right here. 3x with an index of 3, root 4. That's our final answer. Let's do the last one on the page. I've got 54, which we know is 6 times 9. Break 6, you've got 2 times 3, we're at primes. Break 9, we've got primes of 3. And then we've got y to the 9th. And yes, definitely, write it all out. If you don't write it all out, you could end up dropping one and having the wrong answer in the end. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, index says look for groups of 3. I have a group of 3 3s, so they're going to come out, and the only 2 left over, he stays back under the radical sign. I have 3, 3, and another group of, they all grouped up, so I don't have any leftover y's. So out comes the 3 from this grouping right here. Out comes y, and it's in 3 groups, so that becomes my new exponent. Underneath the radical sign with an index of 3 is just my lonely leftover 2. Let's double check. 3 raised to the 3rd power is 27. 3 times 3 times 3. And then 27 times 2 is going to get you to 54. So that matches back. Now I have y to the 3rd, and I'm going to multiply it 3 times in a row. So if I have 3 groups of y's 3 times in a row, I'm going to have 9, which gets me back there. This is the correct answer. 3y to the third, index 3, radical 2. Last examples. Let's break 24. Let's go 2 and 12. And how about 4 and 3? And then 2 and 2. And oh, look fun, we have z to the 16th. You got to write them all out. Guarantee you, the one time that you don't write them out, you're going to make a mistake. You'll drop one of the guys. You'll forget him. There'll be a lonely guy left over that shouldn't be left over. Or you'll have a bunch of leftovers that shouldn't be left over. That's 12, and then our 16. After you do this for a while, you'll end up seeing it quicker, and you won't have to write them out all the time. All right, so we're looking for pairs of 3. I see that I have a group of 3. Looking for groups of 3s. I have a group of 3 and a lonely leftover 3. Now I'm looking for groups of 3 also on my z's. I have 1, 2, 3, 4, and I can grab some more, 5. And I do have one lonely little leftover z. So that means I can take a grouping of 3 2's out, and I can take z. I can take, let's see, how many? 1, 2, 3, 4, 5 z's out. And then my leftovers. I do have a leftover 3 and a leftover z. So there. Double check. 2 raised to the third power. 2 times 2 times 2. That's going to be 8. Then you multiply it by your leftover radicand times 3. That's 24. Good. That gets me back to my original one. Now I'm taking z to the 5th. Make sure we write index 3. So z to the 5th. And I'm multiplying it 3 times in a row. So that's going to give me 15 z's. And then one more underneath is going to give me my 16 z's. So it double checks. This is my final answer, and it's correct. Okay, so let's look at the very last one. I've got 64 m to the 10th. I know 64 is a perfect square. It's 8 times 8. But our index says look for groupings of 3, so I got to keep breaking them down. 4 times 2 and 2 times 2, and I found primes. It's going to be the same thing over here. 2, 4, and then break down 4 again. So we've got a lot of 2's. And then we've got m to the 10th. At least it's not to the 16th. Let's write it all out. Got 3, 4, 5, 6, 7, 8, 9, and then one more is 10. All right, now, remember, groups of 3's. I have one group of 3's, 2 group of 3 2's. That means that both the groupings come out. I don't have any lonely leftover guys. So I have 2 times 2 coming out. Now I have a group of m's, another group of m's, another group of m's, but this time I do have a lonely leftover. So I have 1, 2, 3 groups, so that becomes my new exponent. I've got an index of 3 and just one lonely little m left over. So let's double check. So I've got 2 times 2, that's 4. M cubed. And then I've got an index of 3 and then m. Now, double check says I take 4 3 times in a row. 4 times 4 times 4. So that's 16 times 4. And that will get me back up to 64. And then I'm going to take m to the third 3 times. So that's 3 times 3 is 9. And one more m is going to get me to the 10. This right here is the correct answer. Quick review. In order to find the cube root of a radical expression, first do the factor tree of the radicand. All the prime numbers that can be tripled up, because we're looking for cube root, need to be taken out of the radical sign. Any of the remaining singles, the ones that can't be grouped in groups of 3, have to go back under the radical sign, they get multiplied together, and they become your brand new radicand. It works the same way for your exponents as well. Break them down, circle the groupings of 3, take them out. Any leftovers, go back under the radical sign. Be sure to go back and double check all of your answers, just like we did. And remember, those exponents, they live by the different rules. And that's it for our lesson on radicals, cube roots.